This is assignment 1, and we see two graphs. B is the original function of f, and a is the differentiated function of f dash. This is because when a function is dashed, the slope is increasing more exponentially over a shorter period of time. If we take an example, we can see 3x to the power of 3. Then when it's dashed, it will look like this, 9x to the power of 2. This shows a higher number before x, also equal to more growth. So the conclusion is that the graph B is losing its turning point.
So in the exercise 2, we are set to find the f dash of x and account for the significance of f dash of 1 equals to 0.8. To find the dash version of the function, we have to dash and then we use the natural logarithmic function or the natural logarithmic rule to do that, and then the power rule to differentiate the 0.2x. So the natural logarithmic rule says that we have to take h of x to the dashed and then over h of x. That becomes 1 over x, and then minus 0.2. From there, it is we put the 1 in, and then 1 over 1 minus 0.2. Then it becomes 1 minus 0.2, and then it's 0.8. This means that this function is monotone increasing when x belongs to all positive real numbers.
So in 3A we have been given a task to find the break-even point, or as I say in the assignment, we have to find out where the chemical making and the costs are even. We do that by putting in the revenue function and the cost function, as you can see here, and then we find the point where the two graphs intersect, which is on 44.49, 26,692.6, and in this case this is x and this is y, so y is the cost and x is the liters.
Three, and number B, where we have to find the profit at 150 liters. So I did some preparing here, where I put in the profit function. As you can see over here, it's Q and it's purple, which matches with this. And when we have to find the 150, we have to take that as our x value, because the x-axis symbolizes liters produced and the y value symbolizes profit earned. So 150 and then the Q from up here, and then 150 again, and then you can see we have a point here called L. So I'll just put the value up for it. Then we can see the value at producing 150 liters is 33,110 Danish crowns. So now it's exercise 3 type C, and we have to find the maximum profit. So I have the profit function, the purple one here, and you can see there is a gray one here that is profit function dashed, so derivative of the profit function. When we have to find it, we have to take an intersect point between these two here. As you can see, we'll just pop up here, like that. So we can see that we have an intersecting point of 153.07. That means our max produced liters when we hit the maximum maximum profit is 153.07 liters. So we just do as in type B, we plug in 153.07, and then we do the same with the Q of 153.07, and that should give us a point up here, which will mark our maximum profit. So you can see the maximum profit when producing the maximum here, 153.07 liters, is 33,000 33,156.28 Danish krones. So that is our maximum